Hey, okay, so imagine I'm at the park, right? I'm tossing a beer can, hypothetically, don't tell Lois, and it goes flying. How do I figure out how far it goes if I only know the speed and the angle I threw it? Like, how do I break that whole flying can thing into pieces?
All right, so here's the thing. When something's moving at an angle, it's actually doing two jobs at once. One job forward, horizontal, and one job up and down, vertical. If I know the total speed, let's call it velocity, and the angle from the ground, I can split that velocity into a horizontal part and a vertical part. Why would splitting help? Because horizontal motion and vertical motion don't mess with each other unless Lois shows up, so you can study each separately. So how do you split it? Use some fancy math with sine and cosine. If the throw speed is v and the angle is theta, then v cos theta is how fast it goes forward, and v sine theta is how fast it goes up. Why cosine for forward and sine for up? Seems backwards. What's the intuition? Think of standing and pointing. Cosine is the part along the ground. Sine is the part aiming up. Then what? For how long is it in the air? That depends on the vertical part and gravity. If the ground is level, the time up equals the time down. Using the vertical speed, initial v sin theta, and gravity g, you can find the time until it lands. If you know time, multiply by the horizontal speed, v cos theta, and bam, you've got range, how far the can travel. But what if the ground's not level or there's wind? The can spins like a confused frisbee. Then things get trickier. What if you wanted the maximum distance? What angle should you throw at? Without air resistance, 45 degrees is the sweet spot. With air, who knows, maybe 30, maybe 50, depending on shape and drag. So how would you test that in real life? Would you measure with a stopwatch, use a high-speed camera, or just ask Joe to chase it and report back?